in this video we're going to look at another particle on a sloped surface example, but this one involves friction. So we have a particle of mass 2 kg and it's released from rest and slides down a rough plane, so it accelerates in this direction, which is inclined at an angle alpha to the horizontal. So this is alpha, so tan of alpha is 4 over 3, and from the last question, and you should be able to figure it out now, sine of alpha will equal 4 over 5 and cos of alpha equals 3 over 5. So that's just getting our different ratios for the angle. The coefficient of friction between the particle and the plane is a half, so mu equals a half. Mu doesn't look very good there, but that's a mu. Show on a diagram the forces acting on the particle and then find the acceleration of the particle. So this is a good practice one for the forces again. So we have our particle and there's no force acting on it other than its own gravity really at the start. Okay, so gravity acts straight down. Gravity is equal to mass times acceleration, so its mass is 2 and 2 times g. So sorry, its weight is equal to mass times g. Now what I said to you before was that if that angle there is alpha, when we resolve this into components which are perpendicular and horizontal to the plane, that angle is also alpha. Now where do I get that from? Well, if you look at this here, okay, and I'll just continue that straight. If this goes down straight and I resolve this into two components, horizontal and perpendicular, let's say I drew another line here which is horizontal. Well, because this green line here, this dashed green line, would be the same as this line, and because this is horizontal, that angle would also be alpha, which would make this angle here 90 minus alpha, which makes the top angle alpha. So have a think about that yourself and make sure you can kind of get it, but you can really just learn that that's always alpha. So in the last video then, we said this would be 2g cos alpha, and this would be 2g sine alpha. Now we know cos alpha equals 3 over 5, so that's 2g times 3 over 5, which is going to be 6g over 5. And this will be 2g times sine of alpha, which is 4 over 5. So that's going to be 8g over 5. So are these all the forces acting on it? Well, once it starts to move, once it starts to accelerate down this way, friction is going to oppose its motion. So we have to say, well, friction is acting in this direction. And friction is equal to mu times R. Now you remember what R was. If R was the reaction force, so if we had something on a flat plane like this and its weight was 2g, R would be 2g. But in this case our plane is at an angle. So what do you think R is going to be equal to here? Well, if you kind of turn this on an angle, you'd see that it's going to be the same as this one here, a perpendicular component to the plane. So in that case it's 6g over 5, so R will equal 6g over 5, because that component must equal that component. This component must equal the one that's going down into the plane. So mu would be a half times 6g over 5, which gives us 3g over 5. Now we want to figure out our F equals ma equation. So F or equals ma. Remember, we're looking for the forces in the same direction or same plane as the acceleration. So the acceleration is in this plane. So what forces are in that plane? Well, definitely this one. That force is there, so 3g over 5. And the other force that's in that direction is this one, 8g over 5. Now we assume that it's going to move down the plane. So that means the 8g over 5 must be bigger than the 3g over 5 to get our resultant force, equals 2 times a. And now we can solve for a. Well, that's going to be 5g over 5 equals 2a. 5's cancel. G equals 2a, so therefore a equals g over 2 meters per second squared. And that's your answer. So remember, it's important that when you're getting your F4 equals ma, you look for all the forces in the same plane. All of them are parallel to the actual slope.